right, let's look at our study guide, page 1. The first triangle we're going to look at is ABE. Triangle ABE is located right here. First thing I notice is that it is a right triangle because it has a right angle. Looking at the sides, I see no obvious measurements except for this 7, so that leads me to believe that none of the sides are congruent. So that means it's going to be a right triangle by angle, and it's going to be scalene by sides. Scalene triangles are triangles that have no congruent sides. Now looking at BEC, BEC is located right here. Okay, now I see that BE is equal to 7 units. Now, look at EC. We have a little situation here. EFD, this triangle right here, is equilateral and all the sides are 5. So I know that this side right here is 5 units. So if I take the 5 units that I have right here and add it to the 2 units that I have right here, that tells me that EC is actually equal to 7 units too. So I've got BE, which is 7 units, and I have EC, which is 7 units. So that's going to be an isosceles triangle. That gets 2 congruent sides. Now the angles, if you look at those, are clearly acute angles. So I have an acute triangle by its angles, and I have isosceles by its sides. And remember, isosceles is 2 congruent sides. Now let's look at DEF. DEF is this little triangle. Do you see the 3 congruency marks right here? I've got one here, and one here. So that tells me that my triangle is equilateral. And we have learned in our studies that if you have an equilateral triangle, you also have an equiangular triangle. Each angle is going to equal 60 degrees. So these two go hand in hand. Equilateral is 3 congruent sides. Equiangular is 3 congruent angles. Now we have CDF as our last one. So CDF is this little triangle here in the corner. Now look at this angle right here. Do you see how it's obtuse? So that means that my triangle is obtuse. One obtuse angle and 2 acute angles make an obtuse triangle. If you look at the sides, they're all different. So that's going to be scalene. Okay. Now, on number 2, given the coordinates, classify triangle QRT by its sides. So we have ordered pairs for our triangle. So what we're going to have to do is use the distance formula in order to figure out the length of each side. So we're going to find 3 sides. We're going to find QR. We're going to find RT. And we're going to find QT. Now to find the length of the sides, we're going to have to use the distance formula, which is the square root of, take your x values, -2 and 1, and subtract them. So that's going to be -2 minus 1 squared, plus, do the same thing with your y's, -1 and 5. -1 minus 5 squared. So as we simplify this, -2 minus 1 is -3. -3 squared is 9. -1 minus 5 is -6. -6 squared is 36. So this is going to give us the square root of 45. This will simplify, but we're going to leave it as is. Now let's do RT, our next side. So 1 minus a -8. We're going to square it, plus, let's do our y's, 5 minus a -4, and let's square it. Now, 1 minus a -8 is 1 plus 8, or 9, and 9 squared is 81. 5 minus a -4 is 5 plus 4, which is 9, and 9 times 9, it's going to be 81 as well. Add those two up, 81 plus 81 is 162. And finally, we're going to do Q and T. So -2 and -8 for our x's. So we have -2 minus a -8 plus our y's, which will be -1 and -4. Okay, so -2 minus a -8 is -2 plus 8, which is 6. 6 squared is 36. Plus here, -1 plus 4 is 3. 3 squared is 9. And that's going to give us the square root of 45. So look at your side lengths now. You got the square root of 45 and the square root of 45. That means two sides are congruent to each other. And then the third side is different. So I now know that this is going to be an isosceles triangle because it has two congruent sides. How did I find it? Good old distance formula. All right, number 3 and 4, we're going to find the measure of each missing angle. So starting with number 3, let's see, the first thing that I noticed that I can do right here, this is a straight angle, so I can do 180 minus 88, and that'll give me the measure of angle 1, which is 92 degrees. Make sure you put your degree sign. Let me write this in here. Okay, let's see, the next thing that I can do, since this is parallel to this, if this were my transversal, I can do alternate interior angles, and I can get angle 5 is 81 degrees. Now that I know these two, I can add them up, 81 plus 64, and subtract that from 180. And I'll get 35 degrees for angle 4. Okay. Let's see, where do we go now? We can do 180 for this as well, but we can also look and see that this 92 plus this is going to equal this one right here. So 92 plus x is going to equal, let's see, 81 plus 35, 116, because that's an exterior angle. So that means angle 2 is going to be 24 degrees. Okay, now I can add together 92 and 24 and subtract it from 180 and get 64 degrees for angle 3. And that's number 3. On number 4, let's see what we can do. All right, so I automatically see vertical angles right here, 115 and 4. So that was easy to find. Good old vertical angles. Okay, now let's see what else we can do. If you look at this triangle right here, this big one on the right side, I've got 61 degrees and 90 degrees, which will give me 151. I could subtract from 180. That's going to give me angle 3. Okay. So angle 3 is 29 degrees. Let's write that down. Okay, now look, I got a little triangle right here, don't I? So I can do 115 plus 29. And I can subtract that from 180. And that means angle 6 is 36 degrees. Let's write that down. Okay, so we're making excellent progress. Okay, I can find angle 7 it's a straight angle, 180 degrees, so I can do 180. They don't really give us a lot of room to get all this done, do they? So angle 7 is 144 degrees. All right, I can do right here for 5 and 2, they're vertical, and these are straight angles. I can do 180 minus 115. and get 65. Now 65 degrees is going to be for angle 5 and angle 2. And that leaves angle 1, which is located right here. So I can take 80 and 65, and then once again subtract from 180, and that'll give me 35 degrees for angle 1. Okay, and that's your answers for number 4. 35 degrees, 65 degrees, 29 degrees, 115 degrees, 65 degrees, 36 degrees, and 144 degrees. Now looking at number 5, all of these are in x form. So we can add all of these up and set it equal to 180 because the interior angles of a triangle add up to 180. So we have 8x minus 35 plus 6x minus 5 plus 3x minus 1 is equal to 180. Combine your x's. 8 plus 6 is 14. 14 plus 3 is 17x. Negative 35 and negative 5 is negative 40, and negative 1 is negative 41. So you'll notice I just added the x's, and I added the constant terms, and that's what I get. Over here I have 180. Now I'll solve this two-step equation. Let's add 41 to both sides, and I'll get 17x is equal to 221. Then divide both sides by 17. 17 is going to go into 221 13 times evenly. So that means x is equal to 13. Since it's only asking you to find x, you can stop here. Number 6, we have two interior angles and an exterior angle. The exterior angle theorem tells us the exterior angle of a triangle is equal to the two non-adjacent interior angles added together. So that means I can take 2x plus 20 and add it to 5x minus 11, and it will equal that exterior angle 11x minus 63. 2x plus 5x is 7x. 20 and negative 11 is a positive 9. So again, just add those together. That's all you got to do. And that's going to equal the exterior angle, which is 11x minus 63. So since I have an x on the left and the right, let's move the smallest one to avoid creating a negative. And these two will give me 0. 0 plus 9 is 9. 11 minus 7 is 4x. And then bring down that minus 63. Now we're going to add 63 to both sides. And that's going to give me 72 is equal to 4x. Divide both sides by 4, and we'll get x is equal to 18. Okay, and that's page 1.